Hi, this deck of cards was compiled to facilitate working through standalone questions dealing with scalar and vector quantities. And of course, the content covered is the physical foundations of biological systems. Power is energy divided by blank, which is a scalar divided by a scalar. Hence, it is a scalar quantity. So power is energy divided by what? So power is energy divided by time. Time equals energy over time, or simply equals E over T. So the answer is time, okay? Density is mass divided by blank. A scalar divided by a scalar. Hence, it is a scalar quantity. So what is mass, the dividend, being divided by in order to yield the quotient density? So basically, I'm asking you, what's the divisor here? Density is mass divided by volume. So volume is the answer. Density is rho equals m for mass and V, capital V, for volume. A scalar quantity divided by a scalar quantity is going to yield a scalar. Okay. Capacitance is charge divided by blank. A scalar divided by a scalar, hence it is a scalar quantity. So what divisor goes into the dividend charge to yield the quotient capacitance? I'll give you a moment. Capacitance, denoted by capital C, is equivalent to charge, the magnitude of charge measured in coulombs, divided by voltage. Voltage is the answer. Which is also denoted by a capital V, not to be confused with volume. So a scalar divided by a scalar is going to yield another scalar quantity. Torque is the magnitude of the level arm multiplied by force times blank. This is a scalar multiplied by a vector, hence it is a vector. So what's the missing factor here? Torque, denoted by the Greek symbol tau, is equivalent to the magnitude of the level arm, denoted by lowercase r, not to be confused with a radius, times the force applied to that level arm multiplied by the sine of theta, where theta is the angle. Sine of theta is the force applied and the lever arm. Okay, so here you have a scalar quantity multiplied by a vector quantity, making torque a vector quantity. Force is mass multiplied by blank, which is a scalar multiplied by a vector, hence it is a vector quantity. So what's the missing factor? Force is the product of the mass of an object multiplied by the acceleration.
Acceleration
of
is the
its
answer.
changing velocity, or maybe not changing velocity. So we have a scalar times a vector, making force a vector quantity. Momentum is mass multiplied by blank, which is a scalar multiplied by this missing vector quantity. Hence, it is a vector quantity. So momentum is a vector quantity. So if mass is the multiplicand, what's the missing multiplier to yield the answer of momentum? I'll give you a moment to think. Momentum is the product. It's denoted by a lowercase p of mass times velocity.
Velocity is the answer.
So we have a scalar multiplied by a vector. Therefore, momentum is a vector quantity. Electric field is force divided by blank, which is a vector dividing by this missing scalar. Hence, it is a vector. So what's the missing divisor that yields a quotient of electric field? Electric field, denoted by E, that's a capital E, not to be confused with energy, is the quotient of force divided by a positive test charge in the field. So
it can be negative as well.
A vector
There's a
quantity
charge
divided by a scalar quantity, therefore you have a vector quantity.
All right, so the answer is charge. Electric potential is electric potential energy divided by blank, which is a scalar divided by a scalar, hence it is a scalar quantity. Okay, so what's the missing what's the missing divisor that yields the quotient electric potential? Electric potential, represented by capital E, not to be confused with energy, is the quotient of electric potential energy, represented by capital U, divided by charge. So charge is the answer.
So we have a scalar divided by a scalar, therefore our quotient is a scalar quantity.